So we have just learned two different ways to represent a graph. We learned the general form. Well, hopefully you've watched these videos. We learned the general form, and then we've learned the slope-intercept form. Arguably, when you are asked a question, you will probably be using the slope-intercept form, or the new form that we will learn, the slope-point form. And then you will go and convert that to general form. Now, slope-point form is really useful because it tells you why it's used. It's used when you can find slope, and then you have a single point on your graph. Okay, so here, we actually don't plug anything for these x and y values. They will just be the x and y values that appear in your equation. But y1 and x1 is that point that you're given on your graph. So this is the point found on your graph. So we're going to learn how we can determine the equation of a line using the slope-point form. You have to be able to convert from slope-point form to slope-intercept form. Okay, and you have to be able to justify when you should either use the slope-point form or the slope-intercept form to determine an equation. Because remember, you can always represent an equation or a graph with different equations. So the equation of a non-vertical line in the form, so a slope-point form looks something like this, where you have y minus y1 equals m, which is slope, times x minus x1. We can see below it's explained here. So m is slope, x naught and y naught are two corresponding domain and range values that make a coordinate point that exists on the line x1 and y1. So actually these should say 1 here. Sorry, not zeros. So let's just see how we can determine this equation now. So write the equation of the point of the line that goes through g, -3 and 4, with the slope -2. So always list out what you have. For one, I have my slope, which is -2, and I have a single point on my graph, which is g, and that's -3 and 4. Here, I've been given a single point and my slope, so it's easiest to use off the first, at the beginning, my slope-point form. Okay, so I'm going to determine my slope-point form first. And it's as simple as plugging in these values into the correct solutions. So here, this is going to be my x1 and my y1. That goes into my slope-point equation. So x1 is found here, y1 is found here, and then I have my slope m, which is -2. So this will be y minus y1, and we've just determined that 4 is y1, so minus 4. M was my -2, right? And then x minus, this is important, minus, and I'm going to apply my -3 in here. So I'm going to substitute x1 with -3, so it'll be -3. And then from there, I'm just going to clean it up a tiny bit. I'm not going to manipulate it too much, so I'm going to represent this. Let's actually put it below. I'm going to represent it such as y minus 4 equals -2, x, and then remember, a negative and a negative make a positive, so +3. And there is my equation of my slope-point form. Or sorry, that's my, slope-point form. So there's A. A has been completed. Now let's work on B. So B wants us to put it as our slope-intercept form. So recognize we can convert from slope-point form to slope-intercept form. So convert it. Convert slope-point form to slope-intercept form. And all you're going to do in order to do that is simply solve for y, okay, and then expand these values. So what you're going to do is we're going to write out our slope point form, and we're going to expand and solve for our y value. So the first thing I'm going to do is apply my -2 inside. So this will become y minus 4 equals -2 times x, which is -2x, -2 times 3, which is -6. And then I will add 4. So I get y equals -2x, and then -6 plus 4 is -2. So now we know a ton about our equation, right? We know that we have a slope of -2, and now we know we have a y-intercept at y equals -2. And there is my slope-intercept form. So B is done. Now let's do C. So C wants us to put it in general form. And remember, general form, you need all these numbers to be integers, so 1, 2, 3, 4, 5, 6, and A has to be positive. So I'm going to convert y equals -2x minus 2, which is my slope-intercept form, and I'm going to simply solve for and move everything to one side. So I'm going to subtract y. So I'll get 0 equals -2 minus y minus 2. And everything's in a whole number. The only problem is this has to be positive. So I did forget to write 2x there, -2x, right? -2x. So how do I get rid of that negative? Well, I'm simply just going to multiply everything by -1. So I'll get -1 times -2x, which is positive 2x, -1 times -y, which is positive y, -1 times -2, which is positive 2. And there's my general form. And you are now have written this equation in multitude of different ways. Okay. Now recognize we don't have to do this, but we could easily graph this now. We have a bunch of points to work with. For one, we know where our y-intercept is. It's at -2. So here's -2. Then what else do we know? We know that this goes through -3 and positive 4. So if we wrote positive 4 way up here and -3 up here, we know that this graph will look something like this, where it goes through both of these lines. And of course, I'll fix that up a little bit. And there you go. That's about as good as we'll get it for now. But there's our equation. So this is the graph, y equals -2x minus 2. We could also state it as the equation y minus 4 equals -2x plus 3. Or you could even represent it as 0 equals 2x plus y plus 2. So all of these equations are representing this single graph. Okay? It's all the different names this graph goes by. So it's really important to be able to understand how to go between these three different values and forms. Let's see one other example here. So this other example, it says, determine the equation of a line through -3 and 4 and 5 and -1. So here, we're given 2 points. We're given the points P, which goes through -3 and 4, and we're also given the point R, which is 5 and -1. In order to do A, which is use slope point form, we need our slope. So for y minus y1 equals mx minus x1, we could use either of these points and we'll create the same or the correct answer. The important thing is having the proper m value. So for x1 or y1 and x1, you could choose it to either be -3 and 4 or 5 and -1. Problem is we need to find m. So find slope. And at this point, hopefully you remember all the way at the beginning, how the heck do you find slope when given two points? Well, in order to find slope, we will use our change in y over change in x equation. So y2 minus y1 over x2 minus x1. And then from there, as long as we state these in the correct orientation, so let's say x2 and y2, let's call it these ones. So this is x2 and y2. That would therefore make this coordinate point x1 and y1. So now we can simply plug these into our equations. So y2 I have stated as -1. I'm going to subtract, and now I'm going to subtract it from y1. y1 I have made 4. x2 I have stated as 5. And then x1 I have stated as -3. So remember, there's a subtraction symbol here. And then I'm subtracting x1. x1 is -3. So I'm going to put brackets and put -3. And this is where it's probably a good idea to use your calculator. So -1 minus 4. That gives me -5 over, and then I'm going to do 5 minus brackets -3. That gives me 8. So here I have a slope of -5 over 8, and this equals m. So from here, I have enough points, and recognize that I've already actually stated which one's my x1 and which one's my y1. So I guess we'll just use this point. Again, are you able to use this point? You absolutely are. So let's plug this in. So y minus y1. y1 we have stated to be 4 equals our slope, which we have solved to be -5 over 8. Brackets x subtract x1. What is x1? Well, it's -3. And then from here, we're just going to clean it up a little bit. So I'm going to leave y minus 4 as the proper point, equals -5 over 8 x, and then here negative and a negative make a positive, so this is +3. Okay, so if you're ever given this equation, something to note here is the signs are opposite of what your coordinate points would be. So recognize that if it asked you what point does this graph go through, will it go through -3 and +4? Okay, so it's opposites. And there's your equation. There is a expressed as slope point form. And remember, we technically could have used this coordinate point and plugged it in. It would look a little different, but if you expanded it and converted it to slope-intercept form, you'd get the exact same answer. Okay, so either points would work as long as those points exist on your graph. Now time to do B. And B is putting it into slope-intercept form. So remember, you should be able to convert slope point form to slope intercept form. So convert slope point to slope intercept. So I'm going to take my slope point form. So y minus 4 equals -5 over 8 x plus 3. And what I'm going to do here is I'm going to solve for y. So I'm going to expand this, and this will become y minus 4 equals -5 over 8 times x is simply -5 over 8x, because remember, when these are just sitting beside each other, it means they're multiplying. -5 over 8 times 3. That would be -5 over 8 times 3. And remember, when you multiply a whole number by a fraction, you simply multiply the top number. So this will be -3 times 5, which is -15 over 8. So this is subtract 15 over 8. And then what we can do is we can add 4 to both sides. Okay, and we're going to want to write this out a little bit, so those cancel out. This becomes negative 5 over 8 x minus 15 over 8 plus 4. We have to figure out what this is. So negative 15 over 8 plus 4. In order to add fractions, you need to have common denominators. So remember, we can think of 4 as 4 over 1. And now to get common denominators, we're going to multiply by 8 on the top and the bottom. And we'll end up getting negative 15 over 8 plus 4 times 8. Let's check what that is. 4 times 8 is 32 over 8. And now that you have common denominators, you can simply add the tops. So negative 15 plus 32. So that's 17 over 8. And just to get an understanding of what 17 over 8 is in a decimal, I'm going to do 17 divided by 8. So that's 2.125. So we can combine these, and since it's a nice decimal number, I'm going to put it as a decimal. So negative 5 over 8 x, and actually never mind, I'll leave it as a fraction. So this is plus 17 over 8. And there is my y-intercept form, and recognize there's our y-intercept. Okay, so you would actually be able to graph this. We'll go to C pretty quickly here, but now you're able to graph this really nicely. So if we were to draw our y-axis and our x-axis, okay, 17 over 8, remember that's our y-intercept. So that's 2.125. So if we go up 1, 2, 3, 2.125, well, that's roughly right here. So there's our y-intercept. Okay, and then we were given a point on these graphs. So you not only go through negative 3 and 4, you also go through 5 and negative 1. So let's point those graphs. So negative 3 and 4. So it looks like we'll have to extend this a little bit more. There we go. Okay, and then let's negative 1, negative 2, negative 3. So negative 3 and 4, that's up here. And then points 5 and negative 1. So let's plot that. So we need to go all the way to 5. Ooh, and I don't know if I made this very well. Definitely did not. So it's going to look a little wonky, mainly because look at the distance between these points and these points. Okay, so I might actually quickly fix that up. So it looks like we have to make our increments a little smaller here. So this will be negative 1, negative 2, negative 3, negative 4, negative 5, and then we can do 1, 2, 3, 4, 5. There we go. And then negative 1, negative 2, negative 3. Okay, so let's replot this point. So negative 3 and 4. When x is negative 3, y is positive 4. So our point will be roughly right here. And then our other point was 5 and negative 1. So when x is 5, y is negative 1. So when x is 5, y is negative 1. So that's our point right here. And if we connect these, it forms a pretty straight line. And look at that, it pretty much hits every single point there, which is what should happen based on it being a linear relation. So that's awesome. Goes through all of our lines. Now, we can also check if things worked out. Because recognize our rise over our run is negative 5 over 8. So remember what that means. We go down 5 and right 8 units. So let's check if this works. So we start off at 4 and we need to get to negative 1. So we're going to go down 5. So 1, 2, 3, 4, 5. So this is down 5. And then we need to go right 8 units. So 1, 2, 3, 4, 5, 6, 7, 8. And it looks like we've done everything correctly. Goes through our y-intercept, which we found in our slope-intercept form. It went through our 2 points that we have on our graph. So our equation works really well. Now let's finish off this equation, or this question, sorry, and express it in general form. So remember, in general form, it's easiest to go from slope-intercept to general form because all you do is subtract y, and then you have to make sure your a value is positive and all the numbers are integers. So I'm going to take my slope-intercept form, and I'm going to subtract y. So I'll get 0 equals negative 5 over 8x minus y plus 17 over 8. And remember, in order to get rid of these denominators, we're going to multiply everything by the lowest common denominator, which in this case is just 8. Another thing to note is this is a negative number, and remember, a, because the form is 0 equals ax plus bx plus c, this has to be a positive integer. These numbers simply just have to be integers. So what we're going to do is we're going to multiply everything by a negative 8 because this is going to change the sign of y, or a. Okay, so we're going to multiply negative 8 by everything. And this will become 0 equals negative 8 times negative 5 over 8. Well, that simply cancels out your 8s. Okay, so if you need to see that, negative 5 over 8 times 8, you get your cancels out and your positives cancel out, so you're left with 5. So this will be positive 5x. Negative 8 times negative y gives me positive 8y. And then finally, 17 over 8 times 8. Sorry, let's make that a negative 8. Well, that becomes, these cancel out, 8 and 8, and then your negative times 17 gives me negative 17. So we're left with negative 17. And there is your general form. And remember, this graph here that we've shown can be represented in any of these forms. So your slope point form, your slope intercept form, or your general form. Okay, so this is definitely kind of bringing all the things you've learned into one. You need to know how to go between the forms. And you also need to know when is it maybe best to either use slope point or sloped intercept form. Slope point is easiest when you have a single point and the slope. Slope intercept is when you're given the slope and you know what the intercept is. So you represent it like this or this. And then general form, you usually always go from either slope intercept or slope point form and convert it to general form. Okay, so go practice some questions, come in and ask lots of questions, because this is really important moving forward into our next chapters and also into grade 11 and 12 mathematics. Have a good day.